Hello, algebra students. Mr. Laurence here, and we're going to spend another day on factoring by the GCF. All right, so quickly, to review, remember that factoring, in the word factoring, multiplication is implied. Factors are two things that are being multiplied together to get a product, right? So we're looking for GCF, greatest common factors. We're looking for numbers that are being multiplied uh, as part of the other numbers. So let's see here. I've got 30, 10, and 20. I could think about it as 30 as 3 times 10, and 10 as 10 times 1, and 20 as 2 times 10, making the numeric part of my GCF 10. Now remember, if you're not sure, that should have been kind of an obvious one, but you can take the smallest number 10, list its factors 1 and 10, and 2 and 5, and then you check the other coefficients, the 30 and the 20, and see if 10 is a factor of them. Does 10 go into 30? It sure does, 3 times. Does 10 go into 20? Yep. So 10 is my answer. But it's not the entire GCF. It's only the numeric part of the GCF. Then I need the greatest number of variables that are in common. So over here on this 20, I have an x. Okay, and over here on the x to 10 term, I have a x times x times x, right? And here I have an x times x. Now, you shouldn't be writing all of these out. I'm showing you what's happening. But to do it this way isn't very practical. It will take a way too large amount of time. Remember, I've taught you that the least exponent is going to be your GCF. I'm just reiterating this here. Okay, there are 2 different x's being multiplied here, and there are 3 different x's here. So between these 2 terms, they have an x squared in common. If you want, I could think about x cubed as x squared times x. See the x squared right there? Okay, and this could be an x squared times 1, so therefore they have an x squared in common. However, this term here, this 20x term, doesn't have an x squared. The greatest number of x's they have in common is a plain old x, so my GCF is 10x. All right, so I'm going to get rid of this kind of figuring work here. I'm going to get a larger eraser out. And remember, I have to divide each term by the GCF. So my GCF is 10x. I'm going to divide by 10x here, and I'm going to divide by 10x here. Now when I do that, the GCF goes out front of the quantity. 30 divided by 10 is 3. X squared divided by x, x. Okay, plus the 10's cancel. X cubed divided by x is x squared. And then in here, the x's are going to cancel. X divided by x is 1, not x. 20 divided by 10 is 2. And there you go. I've just completely factored it as far as it'll go. Now, it's possible that this thing inside might factor further. I don't believe it's going to, but you don't know how to do that yet. So, anyway, let's go on to number 2 here. It doesn't look like I gave myself enough room to work, so let me slide number 3 down a little bit. All right, I'm going to go on my hunt for the GCF, the greatest common factor. So first I'm going to do the greatest common factor of 24, 12, and 18. Now, so many of you want to start with 2. 2 is the worst place to start because there's probably a larger number. If you only factor out a 2, you're going to have more factoring to do. It creates more work. So if you're not sure, write down the factors of the smallest coefficient, which would be 12. So 1 and 12, 2 and 6, 3 and 4, and you're done. Okay, now ask yourself, does 12 go in 24? It sure does. Does 12 go into 18? Nope. It can't be common to all 3 terms. Okay, does 6 go into 24? It does. Does 6 go into 18? Yep, my GCF is 6. Well, the coefficient part of my GCF is 6. Now I have to go find the GCF of the x's and the y's. Well, I look and see an x to the 4th, an x to the 6th, and an x to the 9th. Can I write these all? Like x to the 4th times x to the 4th times x squared, x to the 4th times x to the 5th. Now, I could write them lots of different ways, but notice that 4 is the greatest number of x's being multiplied in common. This term here doesn't have any more. Like, I could write this x1 as x to the 5th times x. I could write the x part like that, couldn't I? But there's no x to the 5th in here because there's only 4 x's being multiplied. So x to the 4th is my GCF. It's my greatest common factor of the x terms, that is. So I'm going to have an x to the 4th. All right, now I've got to do my y's. Let me get this x work out of here. Okay, and by now, as smart as you ladies and gentlemen are, you should be recognizing that my GCF is going to be y squared. Okay, let me just reiterate. I could have y squared times y cubed. I could have y squared times y to the 1st, and this would be a y squared times 1. I couldn't say there were more. Like, I could say, well, these two have a y cubed in common. They do. But this one doesn't have a y cubed. So y squared is the y portion of the GCF. So let me get rid of this. All right. So I've got my GCF, 6x to the 4th y squared. So I'm going to divide by 6x to the 4th y squared. Divide by 6x to the 4th y squared. And I'll divide by 6x to the 4th y squared. So that'll come out front. Okay, 24 divided by 6 is 4. X to the 4ths are gone. The y squareds are gone. So it's just a plain old 4. 12 divided by 6 is 2. X to the 6th divided by x to the 4th, x squared. It's division, not multiplication. Y to the 5th divided by y squared is y cubed. Okay, and then I'll have 18 divided by 6 is a 3. X to the 9th divided by x to the 4th is x to the 5th. And y cubed divided by y squared is y. And there you go. We've just factored by the GCF. All right, now number 3 and 4, we've seen problems like this before, but it gave many of you some strange things going on. You didn't like it, but they're really not that hard. Hold on one second here. Number 3, I feel a sneeze coming. Oh, excuse me. All right. Remember, for a GCF, we're looking for factors. Things are being multiplied. Well, I see, on the left-hand term, I see 2 factors. I don't know if you see the 2 I see. I see the factor of x plus 5 and the factor of x minus 4. Yeah, because these 2 quantities are being multiplied. So I'm thinking about this is a number and this is a number. Therefore, they're factors being multiplied. Now, over on the right-hand side, I see an x plus 5. And so I did it in yellow because there's 1 on both sides. And then over here in x plus 7, I did it in a different color because it's not the same as an x minus 4. Well, what do you think my GCF is? What's common? What factor is common? The yellow one, the x plus 5. All right, so I'm going to divide by an x plus 5 on both sides of that negative sign. Now that negative sign is very important. I'm not going to lose them. So I'm going to have an x plus 5, and I'm going to put a bracket here because these are going to cancel, but I'm going to have a quantity of x minus 4 minus, these are going to cancel, and I'll have the quantity of x plus 7. Now you have to be careful here. You have to be careful. Did I mention you should be careful? Look at this. Holly Krieger sees it. Boom. Boom. We have to distribute that invisible 1. Okay, that not imaginary, invisible 1. That's there. Somebody wrote imaginary on their test. So I've got that on my brain because I got to make sure I help them with that. So I'm going to have an x plus 5 times an x minus 4. I'm not going to need the parentheses after I distribute this negative. A negative x and a minus 7. And there we go. Now, I'm going to simplify. I've got some like terms in here. You see my like terms? Let's see here. I've got an x and a negative x. And I also have a negative 4 and a negative 7. So when I simplify this even further, I have this x plus 5. Looks like the x's are going to cancel each other out. X minus x is 0. Negative 4 minus 7 is negative 11. Now, my habits would tell me to write it like this. but this is certainly an acceptable answer, and you would get full credit for it. Okay? All right, let's see here. Same type of problem. Let me scroll down just a little bit. Going to look for my factors. Now there's another factor hiding in here, a GCF hiding in there. I'm going to leave that go for right now. Maybe I'll pull it out in a little bit. So one of the factors is an x squared plus 1. Then I have an x minus 3. Over here I have an x minus 3. And then I have a 6x minus x squared. So it looks like my GCF is x minus 3. So I'm going to divide by a quantity of x minus 3. I'm going to divide by a quantity of x minus 3. That x minus 3 will end up out front. I'll have the quantity of x squared plus 1 plus what's left. It'll be a quantity of 6x minus x squared. Now it turns out that these parentheses are totally unnecessary, so I can drop them out. In fact, I'm just going to go ahead and see if I can erase them. They would be necessary on the right, on the 6x minus x squared term, if this plus was a negative. But distributing a positive does not change the problem, so I don't waste my time doing it. So, hello, James. Would you like to say hi?
Hi, I'm
right.
eating taffy and applesauce.
Okay, buddy. Thanks for the update. All right, so inside these brackets here, I'm going to combine like terms, and it looks like I have an x squared and a minus x squared, and they're going to cancel each other out, and so then I'm going to have a 6x plus 1. Because they're not like terms, I can't put them together. And there we go. We just factored completely. I was thinking about pulling something out of here, and I think it would have made it more complicated to do that, so I chose not to. All right, your video quiz tonight is just 2 problems, factoring by the GCF in both cases. This first one, you'll have to find the GCF of the 3, 6, and 9, and of the x cubed, x squared, and x. And on the second one, we've got the quantity of, don't chew so loud, buddy, close your mouth. They'll think a horse has entered into the video recording room. Here we have the quantity of x plus 1 times the quantity of 3x minus 4. And we have the quantity of x plus 1 and the quantity of 2x plus 3. So you should be able to find a common factor in there. All right, that's it for the video. We're going off to watch Earth to Echo tonight. Mr. Lawrence and James signing off. Good night, everybody.
Bye.